gendered.
In what sense?
Well, I think we're exposed to very powerful social influences from a very early age. And in fact, babies are really tuned to pick up those social influences. And what then happens is the brain is out there searching for rules as to how to establish our identity and how to belong to the right in-group. And if the world's full of gendered rules, then it'll affect how our brains develop.
So that actually affects the physical structure of the brain?
It can affect the physical structure and also the functions of those structures.
But are you saying that there aren't physical differences at birth between male and female brains?
Well, there are certainly physical differences associated with the kind of basic male-female differences, being exposed to different hormones. But I think the differences we're talking about are the kind of brain differences which are, in inverted commas, blamed for gender gaps, gender inequalities, etc. So the kind of things that give people skills and aptitudes and preferences. Babies' brains are really not that different at birth.
So let me bring in Professor Simon Baron-Cohen here. But what would you say that science tells us now about differences between male and female brains?
The sex differences that are found in the brain are not binary. It's not that all males have one characteristic and all females have another. The two sexes show a lot of overlap, but when you compare groups of males and females, you do see average differences.
What would you say those average differences are?
The UK Biobank recently reported on brain scans from over 5,000 individuals and found that on average males have a larger total brain volume, they have more grey matter volume and more white matter volume in the brain. But as I say, these are average differences. They also found differences in different regions within the brain, like the amygdala, which is involved in emotional processing, the nucleus accumbens, which is involved in reward processing. And Gina's absolutely right that these could just reflect postnatal experience, that we're born into culture which influences males and females differently.
But on the first point, Gina Rippon, that Simon Baron-Cohen brings up, the larger total brain volume amongst men, how would you account for that?
Well, of course, one of the things we have to bear in mind is that on average, men are bigger than women, and that's why they have bigger brains. But I think the key thing to be aware of is what those structural differences actually mean. But I think the biobank findings, again, we have to look at those quite carefully and not to get into a kind of science ding-dong, as it were. The understanding of brain plasticity is really important, and the changes that can be made over quite short periods of time by different experiences are really important to bear in mind.
So Simon Baron-Cohen, on the question of the larger brain volume, does that mean, crudely put, that you could argue that men are more intelligent then?
Not at all. All we're observing are differences on average. I mean, Gina makes the good point that you have to take into account other variables, like the person's height or weight. And in the analysis, in the UK Biobank data, they do take all of these factors into account and still find average sex differences.
What does having more grey matter, a larger total brain volume, what does that mean?
We can't say what structural differences translate into. We can just describe that there are these differences. Gina's thesis is that these all reflect the effect of culture, of postnatal experience. Where I think Gina's thesis has difficulties is that you do also find some of these differences between males and females on average at birth. For example, male babies also have more cortical neurons or nerve cells. And if you're seeing those differences at birth, it means whatever the role of culture, prenatal biology is probably also contributing to these sex differences.
Gina Rippon.
I think my thesis really is that nature is very much entangled with nurture. I think we can't separate them in the way that they have really been separated over the last 100 years or so with respect to these arguments.
So just tiny differences there, Simon Baron-Cohen, and the focus should be on what happens culturally.
The other sort of awkward piece of science for Gina's thesis is the role of prenatal hormones. So you can now measure hormones like testosterone during pregnancy in the womb and find that the levels of those hormones, which differ between boys and girls, also predict the size of brain regions that show sex differences in childhood. And since these hormones are being measured long before culture has had a chance to shape our brains, it means that prenatal biology is also having an influence.
Professor Gina Rippon, Professor Simon Baron-Cohen, thank you both.
Thank you very much.
Now, if you're asking what we were asking, is he related to Sacha Baron Cohen? He is. He's a cousin of Sacha Baron Cohen. That's it from us today.